Okay, so we're moving on to systems of three equations and three variables. And yeah, so I'm just going to do a very quick review problem. You should have done this in your intermediate algebra class. This is solving a system of two equations and two variables. Because, well, in order to do three equations and three variables, you should know at least how to do two equations and two variables. And so if you don't know how to do these, you're going to get completely lost when we get to three. So the variables, of course, when we talk about three variables, we're usually going to use x, y, and z, although not necessarily, but that's typical. And for two variables, it's usually x and y. All right, so how do we solve this system, right? Well, there's a number of ways of doing it, and you probably remember the method of substitution, which, we're going to use a little bit eventually, but I much prefer the method of addition. In other words, adding the two equations. But some books call it, and I think this book calls this the method of elimination. Right? So the method of addition or the method of elimination, same thing. Same thing, because you're doing both. You're adding the two equations in order to eliminate one of the variables. Okay, so let's give these equations names. Let's call this A and B, right? Or I can call this the first and the second, or the top and the bottom, doesn't matter. So what are we going to do here, right? We're going to add the two equations, hoping to eliminate one of the variables. And as you probably know, adding the two equations as they are doesn't do anything, right? When you add them as they are, you get 7x plus 9y equals 11, and that doesn't help whatsoever, right? Because our goal is to eliminate either x or y. We didn't do that here, right? So in order to eliminate one of the variables, I need the coefficients to have the same value, just opposite in sign. Okay. So one thing we can do here, if we want to eliminate, let's say we want to eliminate the y, notice that in the first equation, I have a coefficient of positive 6. In the second equation, I have a coefficient of positive 3. But if I multiply 3 times 2, I get 6. So if I multiply 3 times negative 2, then I get negative 6, right? So by multiplying equation B, the bottom equation, by negative 2, here's what I get. I'm going to leave the first equation alone, right? And then negative 2 times 2x is negative 4x, right? Negative 2 times positive 3 is negative 6, right, times y. And then 1 times negative 2 is negative 2. So now I've set this up perfectly for adding the two equations. When I add 6y plus negative 6y, right, I get 0. If I add 5x plus negative 4x, I get, well, 1 times x, right? And this is 0 times y. And this is 10 plus negative 2, right, which is 8. So right away, I get 1x equals 8. So x equals 8. Right? Now realize we're not done, of course, because remember, a solution, when we talk about a solution to a system, it's not just a number. It's a pair of numbers, right? It's an x and a y. We got x. Now we have to find y. So how do we find y? Well, this is where we can substitute, right? We can take this x equals 8 and plug it into either equation. I'll plug it into A. So if x is 8, this is 5 times 8 plus 6 times y equals 10. Right? So 40 plus 6y equals 10. Subtract the 40 from both sides, and you get 6y is equal to negative 30. Divide by 6. Negative 30 divided by 6 is negative 5. So now, here's our solution, right? So this is the solution. X equals 8, y equals negative 5. Or just write it as an ordered pair, 8, negative 5. Okay, so that's the idea here, right? This is the method of elimination. We're eliminating the y's, getting x, right? And in some cases, you might have to divide by something to get x, but in this case, it was already just 1x. And then using that variable, substitute that into the other equation to solve for the other variable, in this case, solving for y. Okay. Again, you've done this before, right? This should be review. Hopefully, this will all come back to you. You know, it might have been a while since you've done this, but that's why I'm reminding you. It's something you haven't done in a while. Okay, so there we go, right? That's solving a system of two equations and two variables. Right, and maybe we'll do one more. All right, we'll do one more quick one. Okay, so here's our system again, two equations, two variables, right? And I never referred to A and B, but I like to refer to the first equation as equation A, second equation as equation B. All right, so let's say we want to eliminate y here, right? Obviously, it's easier to eliminate x, but I want to do this the hard way, right? Or let's actually, how about if we do it both ways, right? Let's eliminate x first. So the bottom equation, equation B, you have a coefficient of 2x. So how do I cancel a 2x? I need a negative 2x, right? So I'm going to multiply equation A by negative 2 on, again, both sides. Right? And that gives me negative 2x minus 4y equals positive 14, right? So that's equation A still. And equation B, we can leave that alone. It's just 2x minus 5y equals 4. So now you add them, right? A plus B. So you're going to get 0x minus 9y equals 14 plus 4 is 18, right? These are both 4s here. Right? And so negative 9 times y equals 18. So just divide by the negative 9. And that gives us y equals negative 2. Okay, so remember, we're looking for a solution. A solution is not just a number. It's a pair of numbers. It's an x and a y, right? So we have the y. The y is negative 2. Now we have to go back and find x, right? And you know how to do that. Plug in the negative 2 in either equation A or B. Either one will work. Or if you do it both, that'll convince you that you have the right answer, right? It's like checking. But I'm going to do this differently, right? Now I want to eliminate y. Right? Eliminate y in order to find x. So we have x plus 2y equals negative 7. That's, again, equation A. And equation B is 2x minus 5y equals 4. Right? So I'm doing this because obviously it's a little trickier because it's not apparent what you have to multiply by to get the other number here, right? I mean, what you could do, right, because in equation A we have a coefficient of positive 2, in equation B we have a coefficient of negative 5. So if I multiply this by negative 5 over 2, then I can get negative 5 as well. Or actually it would be positive 5 over 2 to get a positive 5, right? But that's kind of weird to have to multiply by a fraction, right? So here's the way I like to do it, right? If you multiply equation A times 5, you get 10y, right? And if you multiply equation B times 2, you get negative 10y. Right? So that's the idea, right? Here are the equations again. X plus 2y equals negative 7, and 2x minus 5y equals 4. So, yep, we're going to multiply the first equation by 5 on both sides, and then the bottom equation by 2 on both sides, right? In other words, you're just pulling the 5 from here and the 2 from here, right? So 5 times 2 is 10. They're both going to be 10. Well, one will be positive 10, one will be negative 10, right? So the first equation, you're going to get 5x plus 10y equals 5 times negative 7, so negative 35. And then for the bottom equation, equation B, if you will, you're going to get 4x minus 10y equals 8. So now when you add them, you get 9 times x plus 0 times y equals negative 27. If I did the math right here, yep. So we have 9x equals negative 27. Just divide by 9. And I think you get negative 3, right? So same thing you would have gotten if you just plugged in, say, y equals negative 2 here, right? So, yep. So x is negative 3, y is negative 2. And so our solution should be negative 3, negative 2. Just going to erase the x and put in the solution here, negative 3. So there's our solution, negative 3, negative 2. Okay? All right, so hopefully you have the hang of it. Again, if you look in section, I think 5.1, you can find more examples of this if you need a refresher, and you can maybe try 1 or 2 of those. But in 5.2, we are going to do 3 equations in 3 variables now. Okay, so here's our first example. We have 3 equations in 3 variables. The variables are x, y, and z. And the equations are, well, how about a, b, and c? Right, just to label them. And in this case, I think we really do need to label them because it can be confusing which one is which. All right, so we're still going to use the method of elimination, right? But you can see we have a little bit more choice here. What do we want to eliminate? Do we want to eliminate x or y or z? That's up to you. It's completely up to you, right? So if you want to eliminate x, that shouldn't be hard. If you look at a and b, one is positive x, one is negative x. So all we really need to do before we add them is to change one of them to a negative. So if we multiply b times negative 1 on both sides, well, we get negative x minus y plus 2z equals negative 13, right? So we have that. Right. And now we can just add the 2 equations together, right? So we're going to add a plus b. There's a plus b. So x minus x is 0. Negative y plus negative y is negative 2y. And z plus 2z is 3 times z. And on the right side, negative 6 plus negative 13 is negative 19. So we've eliminated the x, right? And now we have this equation, negative 2y plus 3z equals negative 19. Right? So we eliminated x, but we still have y and z. So yeah, see, this is a little more complicated, right? So what do we have to do? We have to do this again, right? We have to eliminate x again. So we already used a and b as the first pair of equations. So now we can use either b and c or a and c. It doesn't matter to me. Let's do b and c, right? So here's equation b. It's x plus 2y minus 2z equals 13. And equation c is 2x plus 3y plus 2z equals 13. Right. Now you might think, oh, well, if I just add the 2 equations, I eliminate z. The problem is we didn't do that in the previous equation. We didn't eliminate the z, right? The z it's 3z here, right? My z is a little weird, but that's supposed to be a z. Yeah, see the 3z? So eliminating z is not going to help us. We still have to eliminate x, right? Because we chose x to eliminate in the first 2 equations, so we got to stick with that. We have to eliminate x again. So how do I do that here? Well, if you notice, in equation b, we have 1x, and equation c, we have 2x. So how do I get rid of a 2x? Well, make it negative 2x, right? But I can't just put a negative 2 here, right? I have to multiply both sides of the equation by negative 2. Okay, so let's do that down here, right? This is still equation B. We have negative 2x minus 4y plus 4z, right? I got that just by distributing. And then on the right side, 13 times negative 2 is negative 26. Now I can add that to equation C here, which I'm just copying down. Right? And now when we add B plus C, we get 0x, like we did up here on the right, right? Same thing. 0x. Minus 1y, and then plus 6z, and that's going to equal, I think, negative 13. Right? So this is just negative y plus 6z equals negative 13. Right? And now you can see I have two equations in two variables now. So bringing that up here, now I'm in the exact same situation that I was in the first two examples we did. So at this stage, you can take it from here. You know what to do from here, right? In fact, if you want to use the elimination method, or sorry, the substitution method, go right ahead. But I'm going to stick with elimination, right? So what do I want to eliminate now, y or z? It almost doesn't matter. How about y? So if this is negative 2y, I need to make this a positive 2y. So I have to multiply both sides by negative 2 to change it to a positive 2, right? Okay. So, well, I'm running out of letters here. How about if I call this, not C, D and E, right? So this is equation D, this is equation E. So D, we're going to leave alone as negative 2y plus 3z equals negative 19. And then equation E, after multiplying by negative 2, you get positive 2y minus 12 times z equals positive 26. Okay, so far? Well, when we add d plus e now, you can see we eliminate the y's. This is 0y. This is negative 9 times z. And then 26 minus 19 is 7. That wasn't supposed to happen, so hang on. Oh boy. All right, so yeah, I mean, look, this is supposed to come out to a nice whole number here. So negative 7/9 is not going to work. So I must have done something wrong. And see, so this is a pretty good lesson here. This is very tedious, right? We have to do this elimination like 3 or 4 times before we get anywhere. And it's very easy to make a little mistake here. So let me go back to, well, this I think is correct up here. Let me go over here. So B is x plus 2. Oh, okay. I found my mistake. I'm looking at equation B here. Equation B is not x plus 2y. Right? This is plus y. So let's fix that. This should not be a 2y here. There should be a single y, 1y, if you will. And that means this is negative 2y down here. So I got to fix that. Instead of negative 4y, this will be negative 2y. Let me try that again. Boy, I can't write a 2 anymore. There we go. Negative 2y plus 4. So I think that's right. I think that's right. Okay, so now when I add these, I get negative 2 plus 3. I get positive 1y. So that should be a positive y here. Right, and it just looks better, right? So y plus 6z equals negative 13. All right, so now coming up here, this was supposed to be a positive y. In fact, let me just start over here. Okay, that should be better. All right, so equation D was correct. Negative 2y plus 3z equals negative 19. And then equation E, which is this down here, should be positive y plus 6z equals negative 13. Okay. So in order to eliminate the y's here, all I need to do is multiply E by positive 2 on both sides, right? So, yeah. All right. So now, let's go back here. Equation D is still negative 2y plus 3z equals negative 19. And then equation E, after multiplying by 2, I get positive 2y plus 12 times z equals negative 26. Okay, so when you add, D plus E, you get 0y plus 15 times z equals negative 45, right? 50, yep, negative 45, right? So we're almost done. I have 15z equals negative 45. All I need to do is divide by 15, and that tells me that z is just negative 3. Okay. Well, so the hard part was over, and again, it's a little mistake here will really mess you up here, right? I had a 2 accidentally here when it was just a 1. So having fixed that, I think we're on the right track here. Now, I should say going forward, just because you get a fraction as your answer doesn't mean it's wrong. You know, the negative 7 over 9, in some problems, that would be the answer. But if you're getting weird fractions like 208 divided by 114, yeah, it's probably not right. So anyways, z is negative 3, right? But we're not done because remember, we need to find x, y, and z. All we have is z here. So how do we find x and y? So at this stage, if you replace z with negative 3, in either one of these equations, right, you can get y. In fact, let's do it in this equation here, right, which is really just e before I multiplied by the 2, right? So we don't know what y is yet, but now we know that z is negative 3. So I'm running out of space. Let's scroll down a bit here. Yep, so y minus 18 equals negative 13. To solve for y, just add the 18 to both sides. So y plus 0 equals 5. Right? And now we know y is 5. So let's go back up here and erase the y, stick in a 5. There we go. And now we just need the x here. And these commas are a little bit too high here. Trying to make it a little bit neater. Right, so yeah, so now we just have to go back and find x. Right? But we can't use these equations on the right. I'm sorry, we can use these. But we can't use these because there is no x here. There's just y's and z's. So we have to go back to one of these original equations. And as always, it doesn't matter which one, right? It should not matter. So if it's all the same to you, I'm just going to pick the first one, right? X minus y plus z equals negative 6. So I'll do that down here. So it was x minus y plus z equals negative 6. Right. But now we don't know what x is. We know that y is 5. And we know that z is negative 3. So negative 5 plus negative 3 is negative 8. And so x minus 8 equals negative 6. Now just add 8 to both sides. And negative 6 plus 8 is 2. So there you go. X is 2. So go back, and we have our solution, right? It's going to be 2, 5, negative 3. So there we go, right? So so the solution to this equation is three numbers, right? X equals 2, y equals 5, and then z equals negative 3. And don't take my word for it. You can always check by plugging these into all three equations. Don't just plug them into one. You got to plug them into all three, because it could very well work for one or even two, but if it doesn't work for all three, then it's not a solution. And so again, you might have messed up somewhere. It's very easy to mess up here, right? So that's how it works. Again, we started with a rather easy one, so we'll do some more. I think we'll do two more. And yeah, this takes a while, right? Each one is not easy. It takes a long while, and just do it methodically, step by step, and it shouldn't be that bad. Unless you make a mistake like I did, in which case it's very difficult to find your mistake here. Okay. Okay, so on to the next one. We have x plus 3y plus 4z equals 4. All right, so that'll be equation A. And equation B, negative 2x minus 7y plus 10z equals 3. And then equation C will be 2x plus 5y minus 2z equals 5. Okay. All right, first thing you want to do is make sure you write down the correct equations. If you mess anything up here, boy, it's going to be a nightmare. Right? You're going to, well, I mean, you're going to do a lot of work and get nowhere, right? So, okay. Right. So, remember, we want to eliminate either x, y, or z. And I would not choose z here. I would not choose y, rather, because the 3 and the 7 kind of scare me. You would multiply the first equation by 7, the second equation by 3. It's doable, but why bother, right? In fact, I think the x's are going to be just fine. If you just look at b and c, if you add those right now, you eliminate x. So that's the first thing we should do. Just add b plus c. Right, so equation b is here. Make sure you copy it down correctly. Unlike me, I'm prone to making mistakes here. All right, so I think this is fine. And when you add b plus c, you get 0x, negative 2y, plus 8z is equal to 3 plus 5, which is also 8. Right, so, yep, negative 2y plus 8z equals 8. 8z equals 8. Although, everything is divisible by 2. Why don't we just divide everything by 2? Or let's make it negative 2. This will become a positive y minus 4z equals negative 4. Right, now we didn't have to do that, but I like having 1y instead of negative 2y. Okay, so keep this equation in mind, right? We're going to need another equation with just y and z, which means we have to eliminate x again. So we can't use b and c anymore. How about a and b? How about these two equations? So I can't just add them as they are. I'm going to need a positive 2 here to cancel the negative 2. So I'm going to multiply equation A by 2. And if I do that, I get 2 times x. Oh, okay. As long as we don't get too confused here, right? 2x plus 6y plus 8z equals 8. And then for equation B, I can leave that alone. It's negative 2x minus 7y plus 10z equals 3. And now when I add these, let me get rid of the 2 here. I just did that temporarily so I can figure out what I needed to add, what my new equation was, right? My 2a. So now when I add these two equations, you can say 2a plus b. I haven't been doing that. I've just been calling them a and b, right? So you get 0x again. You get negative 1y plus 18z equals 8 plus 3 is 11. Okay, I don't see much way around that. So that'll be negative y plus 18z equals 11. And now, I think what you can see here is, if I get rid of this, there you go. I can just add these two equations together as they are, right? So if I want to eliminate z, I have some work to do. If I want to eliminate y, I can just add them as they are, right? So let's call this equation D and equation E. So D plus E is just going to be 0 plus 14z is equal to 11 minus 4 is 7, right? So scroll down a little bit here. I have 14 times z equals 7. So if I want to solve for z, I just divide by 14. So I get z is equal to 1/2. Right? So that seems reasonable, right? There's no problem with fractions here. So when I write my solution, so let's write the solution up here. It's going to be an x, a y, and a z. We know z is 1/2. Right? Now we have to find x and y. Okay? Yeah. So in fact, that's right. This is the hard part, is just eliminating the same variable twice. In this case, I eliminated x twice, right? Just like last time, example 3. Okay, so how do I find y? Well, look at this equation, right? I have y minus 4 times z equals negative 4. All I have to do is substitute z equals 1/2 in this equation. So if I plug in z equals 1/2, what do I get? I get y minus 2 equals negative 4. So add the 2 to both sides. I get y equals negative 4 plus 2 is negative 2. Okay, so y is negative 2. Yep, erase the y, put in negative 2 here. Negative 2. And now we just need x. So how do I find x? Go back to one of these. Any one doesn't matter. I'm just going to pick equation A. Right? So that's x plus 3y plus 4z equals 4. And now plug in the numbers we do know. We don't know x, but we do know y is negative 2. And we know z is 1/2. So we get x minus 6 plus 2 equals 4. Negative 6 plus 2 is negative 4. All right, so be careful because we're going to add 4 to both sides here. So we don't get 0, we get 4 plus 4. All right, so x is going to equal 8. And there you go. I think that's our triple, ordered triple of numbers. X is 8, y is negative 2, and z is 1/2. Again, you should check the other two equations as well. Plug these in B and C and see if they work. And they should. So, right, so there it is again. And again, I took the easy route by eliminating x first, but you don't have to. You can eliminate z, you can eliminate y, whichever you think is easiest, right? So there's a lot of ways of doing these. And, you know, in my suggestion is just take the path of least resistance, whatever you think is easiest, right? Just do it carefully, right? Don't mess up any of the arithmetic, because that can drive you crazy sometimes. Believe me, I know how frustrating this is. If you miss one little sign somewhere, that can completely mess up everything. So just do it carefully. Okay, on to the next one. So here we are. We want to solve this system. So equation A is 6x minus 5y minus 4z equals 4. Equation B should be 3x plus y minus 2z equals 9. And equation C is 5x minus 3y plus 6z equals 15. Making sure that's correct. Okay, good. All right. Well, remember our solution will be an ordered triple. We're looking for x, we're looking for y, and we're looking for z. All right. So what do you want to eliminate first? X again? We could. I mean, obviously, if we just multiply this by -2, we get -6 and +6. That's fine. But then, what do you do with the 3 and the 5, right? You multiply one by 5, the other by -3. So, a bit of a hassle, but it's doable. On the other hand, anytime we see a 1, right, this is just one y, I think that's what I'm going to go for here. I'm going to try to eliminate the y's first. Okay, so let's just look at equation B. Equation B is 3x plus y. Oh, I should do this in yellow, right? 3x plus y. Here we go. Minus 2z equals 9. And if I want to eliminate, let's do B and C first. If I want to eliminate the y, and in equation C I have a -3y, then I need this to be a +3y, right? So we're going to multiply both sides by 3, right, to cancel the -3y up here, right? So I erase all that. Okay, so when we do this, we're going to get 9y plus 3y. So, let me say that again. 3 times 3x is 9x, not 9y, right? And then 3 times y. And then 3 times -2z is -6 times z. And then 9 times 3 is 27, right? So that's still equation B. Now we add equation C to the mix. So this is 5x minus 3y plus 6z equals 15. Okay, so let's add B plus C. We get 9x plus 5x, that's 14x, right? 3y minus 3y is 0, so that's good. And -6z plus 6z, hey, that's also 0. Wow, I didn't expect that, but that's a nice bonus. We eliminated both y and z right away. Okay, the right side, however, is 42. So we have 14x equals 42. Divide by 14, and I think x is 3. So, right. So this worked out really well, a lot better than I expected. Right? And don't expect this to happen every time, of course. But this is nice, right? So if you get x right off the bat, then we might as well just plug in x in, let's say, A and B here. So equation A is going to be, I'll try to write small here, 6 times x, but x is 3, minus 5y minus 4z equals 4. So that becomes 18 minus 5y minus 4z equals 4. Subtract the 18 from both sides, and you get -5y minus 4z equals -14. Okay. So let's do that for equation B as well. So this is still equation A. If I have room on the right here, we have 3 times x, but x is 3, right? Plus y minus 2z equals 9. So that's going to be 9 plus y minus 2z equals 9. Well, that's nice. 9 minus 9 is 0. So we get y, oops, not plus, minus 2z equals 0. And that was equation B. So at this stage, right, we can eliminate y again. Multiply the bottom equation by 5, right? So, yep, if we multiply this by 5, we eliminate y, and we can find z, right? Again, there's other ways you can do this, but that's the way. Looks like it's going to be easiest this way, right? So that's minus 14. Let me try that again. Minus 14 here. Okay, and equation B is positive 5y minus 10z equals 5 times 0 is still 0. So when you add these, you get 0y. You get negative 14 times z equals negative 14 plus 0, which is negative 14. So divide by the negative 14, and we get z equals 1. Okay, so yep, z is 1. And now all we have left to do is to find y. And here's how I'm going to do it. This is very easy here. At this stage, we have y minus 2z equals 0. So if you add the 2z to both sides, you get y is equal to 2 times z. But we know what z is, right? Z is 1, right here. And so y is 2 times 1, or 2. So there we go. Yep, x is 3, y is 2, and z is 1. So we get 3, 2, 1. Again, that worked out pretty nicely, right? So this one, I don't know, in my mind, looking at this looked a lot harder than it was. And maybe we got lucky, right? On the first go around, we ended up eliminating both y and z all at once. Yeah, so that doesn't always happen, but hey, it happened here, so I guess be thankful that they're not all going to be that difficult. So I'll try to find a harder one, and so let's do another one, and yeah, I'll try to make it harder, but no guarantees, right? Okay, last one. And so this is my equation A, B, and C. And so again, we're looking for the solution. It will be an order triple. I'm not going to put in the x, y, and z here. I'm just going to put the commas and to be filled in later. Okay, so yeah, this one's maybe not that much harder. So you can eliminate x, right? You can eliminate y. But notice there's a lot of 1s here for the z. So I think I'm just going to eliminate z first. And if you just do b and c together, just add them as they are, you cancel out the z's. So let's write them over here. 3x plus 4y plus z equals negative 10. And then equation C is 5x plus y minus z equals 1. So when you add these together, you get 8x plus 5y plus 0z equals negative 9. Okay, so there's one equation without a z in it. That's supposed to be an 8, right? Okay, it's supposed to be an 8. All right. All right, so now we have to eliminate z again. And we could do a and b, but then we'd have to multiply one of these by a negative, right? So why don't we just do a and c? So equation A is x plus 7y plus z equals 3. And then equation C is 5x plus y minus z equals 1. Well, let's add them together, right? This is a plus c. Sorry, this was b plus c over here. So we're going to get 6x plus 8y plus 0 equals 4. And notice they're all multiples of 2, so I can divide by 2, although you don't have to. Yep, that looks a little bit better. 3x plus 4y equals 2. So now I have my two equations in two variables. Right? You can take it from here. Well, okay, so, pause the video and try to work this out on your own. Yeah, so let's, all right, so let's do that. So what can we do here now? Well, we can eliminate x. Oh, I'm going to move this over. Hang on. There we go. A little more space here, right? So we, I guess I'll call this equation D and equation E. You can see there's no good way to do this, right? There's no easy shortcut here. So I think we're just going to have to multiply. If I want to eliminate the x, I could do 8 times 3 is 24. So multiply the first equation by negative 3, the second equation by positive 8. Right? So negative 3d is going to be negative 24x minus 15y. And then negative 7 times negative 3 is positive 21. It's supposed to be a d here. There we go. And then 8 times e is going to be positive 24x plus 32y equals 8 times 2, which is 16. Right. And that was by design. We can now eliminate the x, right? Negative 24x plus 24x is 0x, or just 0. 32y minus 15y is 17y. And then 21 plus 16 is 37. That's not good. I mean, look, 37 over 17 is not a nice number. I mean, that might be it, but I kind of doubt it. So I must have done something wrong here. Give me a second and I'll try to find it. Or better yet, you try to find it. But I know I did something wrong somewhere. Actually, I hope you didn't look for my mistake, because there isn't any. This is correct. So yeah, I did make a mistake, of course, but it's in writing down the problem. If you solve this, I think you get this. It wasn't negative 10 here. So again, this was my mistake. It was supposed to be a positive 10. So there you go. Let's make it a positive 10. And that means in equation B, this was supposed to be a positive 10. All right? And so when we did B plus C, we should have gotten 10 plus 1, which is 11, not negative 9. So to fix that, 10 plus 1 is 11. Yeah, I'll use green for the corrections, right? So this was the correction here. It was positive 10 instead of negative 10. Okay, so I think A and C, I think those were fine. So there's nothing wrong with this. But now going down here, 8y plus 5y was 11. Oh, maybe that was another mistake here. Yeah, 3x plus 4y is 2. That's fine. That was supposed to be a negative 9 anyway, right? So I messed up twice, right? So this is supposed to be an 11. Okay. And so now, I think this number is wrong. Negative 3 times 11 is negative 33. So I can fix that. Negative 33. And now when you add negative 33 plus 16, you don't get 37. You get negative something. looks like negative 17. Okay, so let me change that here. This is negative 17. And so this works out pretty well. This was not supposed to be 37. It's supposed to be negative 17 divided by 17, which is just negative 1. So y should be negative 1, and that looks a lot better. Okay. So, sorry about that. Y is negative 1. All right. Now what? Well, if y is negative 1, now we can find x through this equation. Just replace y with negative 1. So you get 3x minus 4 equals 2. Add the 4 to both sides. You get 3x equals 6. Divide by 3. X is 2. So, yep, x is 2. And now just to find z, well, we can use any one of these three equations here. Oh, yeah. So I always use the top one, so I'll stick with that. I'll use equation A again. Equation A was x, right? X plus 7y plus z equals 3. So if we plug in x equals 2 and y is negative 1, we should be able to solve for z. So 2 minus 7 plus z equals 3. 2 minus 7 is negative 5. And negative 5 plus z equals 3, so add the 5 to both sides. You get 0 plus z equals 8. So z is 8. And there's our solution. So 2, negative 1, 8. Right. And don't forget to check, right? Plug them back into equation B and C. Oh, you should try A as well, but if A messed up, if you plug it into A and it doesn't work, then that means we did something wrong here. So I think double check all my arithmetic. I think this is correct. This is correct. And y was negative 1. So, yep, I had to hunt for my little mistake here. And, yep, one little negative sign will throw you off entirely. So, all right, I think I better end this here. Yeah, so we did 3 of these. Try some more for homework, and if you get stuck, just ask questions, and I'm happy to do another one by request. So, but this was long enough. We did 2 systems of equations with only 2 variables, and we did, I think, 4 of them with 3 variables. So hopefully that's enough. Okay, I know this is a long video. I just realized that I think we need to do another one. Okay, so some of the questions in the homework I think are word problems. So I'm going to write down a word problem, and then let's see if we can solve it. Yeah, so I was considering just making a separate video, but I think we'll continue here. All right, last example. I promise this will be the last one. So this is a word problem. So it's an application of solving systems of equations. And I know if this is a little tiny, let me read it. I just pulled this from my notes. We have a theater has a capacity of 4,000 seats, divided into 3 sections, which they call A, B, and C. Section B has twice as many seats as Section A, and Section C has 1,000 more seats than Section B. How many seats are in each section? And yeah, that should be a question mark. How many seats are in each section? So there we go, question mark. Okay, yeah, so that's the question. So what they're looking for is how many seats in Section A, right? So how many seats in Section A? Right, And again, how many seats in section B? And how many seats are in section C? Okay, so that's the question. Right. And so let's read this carefully, because every statement has a clue here, right? Every one of these sentences has a clue. The first sentence says a theater has a capacity of 4,000 seats, right? So if there's only 3 sections, right, then when you add up section A, section B, section C, then we get 4,000 seats, right? So that's the first statement. That's my equation 1. I'm not going to use A anymore, so now instead of x, y, and z, right, our variables are A, B, and C, which just refer to the sections. I mean, if you want to use x, y, and z, be my guest, but I think A, B, and C works just fine here, right? Okay, so what else do we know? We know that section B has twice as many seats as section A. So if A has, 200 seats, then B has 400 seats, twice as many, right? So section B has twice as many as section A. B is 2 times A. Make sense, right? If A has 100 seats, B has 200 seats, and so on. All right, but we need a third equation. So where do we get the third equation from? Section C has 1,000 more seats than section B. Right? So C has even more than B does by 1,000, right? So if B has 500 seats, then C has 500 plus 1,000, right? So C is just whatever B is plus an additional 1,000 seats. So section C has 1,000 more seats than section B. I think that's right. Okay? But there you go. There's our 3 equations in 3 variables. So that's all we need. The difference here is that these are written in a kind of a clumsy order. Notice that we never had variables on the right side. They've all been on the left. So in keeping with that, you could write the 3 equations this way. Right? Subtract the 2a, we get negative 2a plus b. Well, that would be 0. And then if we subtract the b here, we get negative b plus c, and that's still going to be 1,000. So we can, write this in the usual way here. It's not completely necessary, but why not, right? Just to make it look like the previous examples that we did here. Okay, so what should we do here? Well, eliminate, right? What do we want to eliminate? We can eliminate A if you want, right? If I multiply the first equation by 2, that'll cancel the negative 2. Yeah, I guess let's just do that, right? So here's the equation 1 again. Let's just multiply by 2. So 2a plus 2b plus 2c is equal to 2 times 4,000 is 8,000, right? And leaving equation 2 alone, we already have the negative 2a plus b equals 0. When you add these, you get 3 times b plus 2 times c equals 8,000. Okay. Well, if you notice, the bottom equation here, equation 3, also just has b and c. So let me just copy that down. And so now we can call this equation 4 and equation 5, since I'm running out of numbers here. And we want to eliminate b or c. I'll do b. Just multiply by 3, and that'll cancel the positive 3b here. So equation 4, I'm going to leave alone. 3b plus 2c equals 8,000. And if I multiply this by 3, again on both sides, I get negative 3 times b plus 3 times c equals 3,000. Is that right? No, I think I messed up again. All right, hang on. Let's try to figure this out. So 4,000, negative 2b B has twice as many seats A, so I think that's correct. C has 1,000 more than B, that's correct. Okay, I don't think I did anything wrong here. Multiply the first equation by 2, that's fine. Okay, and then multiply by 3. Huh. All right, hang on. I'll figure it out somehow. Okay, I don't know why I think this is wrong. I think this is fine. Let's go ahead. So 2c plus 3c is 5c. That's a 5. And then 8,000 plus 3,000 is 11,000. So I thought I would get a really weird number here, but it's not. If you divide by 5, divide both sides by 5, 11,000 divided by 5 is 2,200. Not a crazy number, right? That's 2,200 seats for section C. So that answers the first question, or that answers one of them, right? So now what do we need to do? We need to find how many seats in section, how about B? So notice that this equation here has just B and C. So negative B plus 2,200 is equal to 1,000. All I did was replace C with, right, 2,200. Okay, subtract off the 2,200. And negative B is going to be a negative number, right? B should not be negative. B should be positive, but I think that works, right? So let's see, 22 minus 10 is 12. So this is negative 1,200. Yep. So divide by negative 1, and B should be positive 1,200. So, yep, 1,200 seats in section B. And now this should make sense, right? Section C has 1,000 more seats. 1,200 plus 1,000 is 2,200. So I think we're on the right track. Now we just need A. So again, you can use, obviously you can't use equation 3, there is no A here, but you can use either equation 1 or equation 2. And I don't know about you, but 2 looks pretty easy here. B is just 2 times A, so that means A is just half of B. Or better yet, let's just write this down, right? 2A is equal to B, and we know B is 1,200. So if 2 times A is 1,200, divide by 2, A is 600. Right? 1,200 divided by 2. So there you go. There's 600 seats in section A, 1,200 in section B, which is twice as much, and 2,200 in section C. So the only thing left to check here, I think, is when you add them all up, do you really get 4,000 seats? And yep, you get 1,800 plus 2,200, which is indeed 4,000 seats. So it's a good way to check. So there we go, right? 600 seats in section A, 1,200 in B, 2,200 in C, and that answers the question. So we're doing the same thing. We're solving a system of equations in 3 variables. Again, there's many different ways we could have done this. You could use substitution here. That almost makes sense, right? Plug in B is equal to 2A, then you get your A and C, plug it in here. That would have worked as well. So I'm kind of going on the same method that we did the last problems, just solving by the elimination method. But in some cases, substitution will work as well. So, so I hope that's it. Yeah. So you're not going to see a lot of these word problems. Maybe 1 or 2 in the homework. So you might want to try one of those and see how it goes. But mostly I would expect just an ordinary system of equations without the word problems. In fact, the word problem is a little bit trickier because it really depends on if you translate these words into the equations, if you get the wrong equations, you're going to get the wrong answer, right? So you have to make sure your translations are correct. And then, once you get, if you have the right equations, if you make a mistake in solving them, again, you'll get the wrong answer. So there's a lot of ways to go wrong here, and you can see I was second guessing myself. I almost went wrong, but I think I did this okay. So I hope this works. So good luck. This is try the homework problems.